right, so on the next page, we're going to be talking about proportion. So a proportion is an equation in which we're setting two ratios equal to one another. So a proportion is going to look like us setting two ratios or two fractions equal to one another. How we're going to solve a proportion is we're going to cross multiply. So if we're given a proportion, one way that we could solve a proportion is cross multiply. So I'm going to multiply A times D, because that's the cross product of this diagonal. And then I'm going to set that product equal to the product of the other diagonal. So AD would equal BC. So we're going to be solving some proportions in the next several examples. The next problem asks us to find the second proportional of 1, 2, and 3. So in a proportion, we're going to be setting two ratios equal to one another. So there's going to be like 4 positions. So we're setting two ratios or fractions equal to one another. So there's a numerator, denominator, numerator, denominator. So there's 1, 2, 3, 4 positions. So if I want us to find the second proportional of 1, 2, and 3, what I'm basically saying is, I don't know what the second value in this proportion is going to be. So I want us to find the second proportional. I don't know what the second value is when I line up these numbers in order. So I know that the first number in the proportion is going to be 1, because that's the order that it's listed. The second proportional is the unknown. So that's going to be the denominator of the first ratio. Then the next number that's given to me that I do know, so the third proportional here, oops, sorry, I said 3, I meant 2, is going to be 2. And then the fourth proportional is going to be 3, because that's the last number that's listed. So here's our proportion. And in order to find the value of x, we're going to cross multiply. So the first cross product, 1 times 3, is going to give me 3. And that's going to be equal to the second cross product. So x times 2, or 2x. And then we're going to solve this for x. So we'd have to divide by 2. So x would be equal to 3 halves, or 1.5 if you want to write it as a decimal. The next one says find the fourth proportional of 6, 9, and 5. So here, because it says the fourth proportional, I don't know what the fourth position in this proportion is going to be. So again, in a proportion, we have like 4 slots. So here's like slot 1, slot 2, slot 3, and slot 4. So I don't know what the fourth proportional is. So that's why I'm leaving that as an unknown. The other positions, I'm just going to write in the order that I see them. So 6 is the first, 9 is the second, 5 is the third. Again, the first one, we didn't know the second proportional. So that's why I filled in like the second slot with x. I filled in the remaining spots just in the order that they were written. So what I can do next, solve the proportion, so I can cross multiply. So the first cross product, is 9 times 5, which is 45. We're going to set that equal to the second cross product, which is 6 times x, or 6x. We're going to divide by 6 on both sides, and that's going to give me 7.5 for the value of x. So for 7 and 8, we want to find the ratios of x to y and y to x. So for the first one, I'm given 7x equals 10y. I want to find the ratio of x to y. Or if I write this ratio, x to y, as a fraction, I want it to be x to y. So what I'm really interested in is, what is the ratio of x to y equal to? What is this fraction over here? We're going to use this equation to kind of work backwards to build the proportion. So if I had a proportion and I were to cross multiply, I'd be multiplying x by, well, based on this equation, I had to multiply x by 7. So 7 would have to go here in the proportion so that when I cross multiply, I get 7x. If I cross multiply the other way, the other diagonal, y times what would have to give me 10y? Well, that would have to be then 10. So the ratio of x to y would be equal to 10 over 7, because that's what it is equal to in this proportion. Now, number 8 says find the ratio of y to x, but this one's a little bit more complicated. I already have a proportion here, but on one side, I do not have y to x. So the very first thing that I'm going to do is I'm going to cross multiply. So the first cross product, I'd be multiplying 4 by the quantity x minus 6. And that would be equal to the other cross product, where I'd be multiplying 3 by the quantity y minus 8. And I'm going to use my distributive property on both sides. So I have 4x minus 24 equals 3y minus 24. And I want to combine some like terms because I have a constant on the left and a constant on the right. But notice if I try to bring this negative 24 by adding 24 to both sides, the constants end up canceling out. So now I have something similar to the last problem. So what I'm interested in is figuring out the ratio of y to x, or y to x as a fraction. So again, I'm going to kind of work backwards to figure out, well, what did I have to multiply y by to get to this equation here? So it says 3y. So I'd have to have a 3 here for me to have a product of 3y. Then if I cross multiply this way, x times what would end up giving me 4x? Well, that means 4 would have to be here. So the ratio of y to x would end up being 4/3 or 4:3. For the next set of problems, we are going to be solving some proportions. So for number 9, it says solve each of the proportions for x. Also this one, we're going to be solving for z just because that is the other variable there that I'm using. So for number 9, we could start out just by directly cross multiplying. Another thing that I want to point out that you could do is if one of the ratios can be simplified, you could start by first simplifying the ratio. So these numbers aren't like too big, and you could use a calculator if you need one, but if I wanted to make these numbers a little bit smaller to work with, I'm not changing the left, but I noticed that 28 and 50 are both even. So they both have a common factor of 2 that I could remove. So I could first start by simplifying this fraction, which would give me 14 over 25. Then I could cross multiply. Just an option, if you have a ratio on one side that you can simplify, you are able to simplify that first before you cross multiply. So if I cross multiply now, I'm going to get 14x for one cross product and 175 for the other. If I divide by 14 on both sides, I will get x equals 12.5. Number 10, now, again, we're going to be solving for z, not x, because that's the variable I'm using in number 10. So the first cross product, I'm multiplying the quantity z minus 4 times the quantity z minus 4. And I'm going to set that equal to the other cross product, which is 5 times 20, which is 100. Now, what we're going to be practicing in the next two examples is distributing or FOIL, whichever method you've heard that by. FOIL just stands for the order in which you're multiplying. First, outer, inner, last terms. So you just want to make sure that you multiply every term in the first quantity by every term in the last quantity. So if I do z times z, for the first, that's going to get me z squared. If I do the outer terms, that's going to give me negative 4z. If I do the inner terms, that's going to give me another negative 4z. And if I do the last terms, that's going to give me a positive 16. If I combine the z terms, that's going to give me negative 8z. We have a quadratic, which we're going to have to solve by factoring because we do have a linear term or a z to the first power term. So to factor, I need to get 0 on one side, so I'm going to subtract 100 over to this side. 16 minus 100 will end up giving me 84, negative 84, excuse me. So this one's a fairly easy factoring problem because technically there's a 1 in front of the quadratic term. So we need to think of factors of negative 84 that add up to negative 8. Now, negative 84, that is a kind of like a larger number, more than we've been dealing with when we have to factor. So you can absolutely use a calculator if you need to. We need to think of factors that multiply to 84 but add to negative 8. So maybe if you're not sure, let's just start coming up with some factors of negative 84. So factors of 84, for example, 4 and 21. But I will end up needing one of these to be positive and one of these to be negative for me to get a negative 84. So if I subtracted these two numbers, I don't get 8 or negative 8. So I gotta try again. So maybe I decide, let's see if 84 is divisible by 6. And it is. 6 and 14 are factors of 84, but I will again need one of these to be positive and one of these to be negative. If I end up subtracting these numbers, I do get 8, but I need it to be negative 8. So I am going to need the larger number, the 14, to be negative and the 6 to be positive. So if I multiply 6 and negative 14, I get negative 84. If I add 6 and negative 14, I get negative 8. And then to solve, we have to set each factor equal to 0 and solve. So we'll get z is equal to negative 6 and z is equal to 14. The next one, we're going to do the same thing. We are going to first start by cross multiplying. I'm then going to FOIL or distribute over here. I'm gonna combine my like terms. Again, I will have to factor because I have a linear term, an x to the first power. So I need to bring 18 to the other side. So I'm gonna have to subtract 18 from both sides. Now, this is a little bit of a harder factoring problem because the a value, or the term in front of the x squared, is a 2. Now, you could solve this a couple of different ways. You could solve by factoring a couple of different ways. What I'm going to go through is a method that we went over in class a couple times, but I just want to give us a refresher on it. So what I'm going to do is set down parentheses, and I'm going to put this number in the first slots of the set of parentheses with an x attached to it. I'm then going to multiply the a value in the quadratic by the c value. So typically, quadratics are written in this form. So a times c, so 2 times negative 21 is going to give me a negative 42. I need to think of factors of negative 42 that are going to add to the b value, which is 1. So I need to think, what are two numbers that multiply to give me negative 42 but add to positive 1? So that's going to be 7 and negative 6. So 7 and negative 6. And I'm going to put those numbers, 7 and negative 6, in the last slots. I'm not quite done yet though. I need to look at each binomial and find the binomial that has a GCF. So it's the second binomial that has a GCF of 2. So I'm going to remove that common factor. So if I divide 2x by 2, I get x. If I divide negative 6 by 2, I get negative 3. I need to solve this for x, so I'm going to set each set of parentheses equal to 0 and solve. So here x would equal 3. Here x would equal negative 7/2 or negative 3.5. So that was just a little bit of a harder factoring problem. The last problems that we're going to do talk about geometric mean. So geometric mean means that we have a proportion in which the second and third terms are equal. So what that would look like is, again, in a proportion you have like 4 slots. So if I want to determine the geometric mean of 4 and 16, it means technically that the second and third terms are equal. So here we have like first, second, third, fourth slots in the proportion. So the second and third terms are equal. And they're unknown. So the other 2 slots are going to be taken up by these numbers, 4 and 16. So if I cross multiply, I'll get x squared equals 64. And if we take the square root of both sides, we're going to technically get x is equal to positive or negative 8. In the geometric mean though, we always want the positive root. So we just want 8, not negative 8. A little bit of a faster way to do this, instead of like actually setting up a proportion, is what we could do to like shorten the process is we could multiply these 2 numbers together which is 90, and then take the square root of that number. If we take the square root of 90 and we put it in simplest radical form, we're going to get 3 times the square root of 10. And again, we just want the positive root, not the negative one. How I came up with 3 times the square root of 10 is I thought about factors of 90, one of which is a perfect square. 9 is a perfect square. So I took the square root of 9. When it came out of the radical, I took the square root of 9. That's how the 3 came out. The 10 remained under the radical.